So hello everyone, this talk is called Maintaining an Open Source Library for Next.js, Feedback and Tips. I will start by thanking the sponsors, particularly Bear Studio for organizing this event and allowing me to speak at my first tech conference. So please bear with me. So before we start, I can do this in light mode or dark mode. So this is dark mode and this is light mode. Show of hands for light mode. Yeah, and dark mode. Oh, wow. I was actually expecting the other one. Never mind. This is the web. We can do whatever we want. And it's free also. So what to expect from this talk? I realized that the title is a bit different to the actual content. We are mostly going to be talking about web standards, web app behaviors, design, and best practices. So there is no actual requirements of experience with either Next or React. I will be introducing some terms as I go along. My name is François Best. You can find me on the social network formerly known as Twitter under the handle 47effects. I'm a freelance web developer. I work mostly with TypeScript on mostly the front end with Next and React, but I often dabble into the back end with Node and Fastify. Fastify it's like a replacement for Express to build APIs. If you don't know it, try it, it's awesome. So I've been doing freelance web dev since 2018, and before that, I was working in the pro audio industry. We were going into recording studios, gathering vintage analog audio equipment like consoles, equalizers, compressors, and we were turning them into digital plugins using C++. So this is what we called native code. Native code is code that you have to compile, you package it into an installer, and then you sell it, hopefully, to your users, and then your users will install it. And usually that's where the story ends. Your product becomes locked both in space and in time. In space because it only works where you've installed it, and in time because you need to manually update it to have the latest version. So this is a bit tedious. And so about 8 years ago, I'm not that old, I started looking at web technologies. Back then, all the rage was with AngularJS, Vue 1, and React just before the hooks came out. It was the beginning of the end of the days of jQuery. And we could build very, very quickly with this. So I could build my applications, iterate quickly with it, and deploy them even quicker. I could git push my code, and a server somewhere on the web would build it for me, and I could access it instantly. There is no gatekeeping system like an app store between me pushing the code and accessing it directly. And this is the beauty of the web, and it boils down, I think, to one thing. The web has a superpower, the URL. So with URLs, we can share them. I can send you a link, you can click it, and you can access the website from anywhere in the world. So this breaks the concept of software being locked in space. You can access it from anywhere. You can bookmark them, which is arguably a way to share it with yourself in the future, which breaks the concept of being locked in time, because whenever you will open that URL in the future, you will always have access to the latest version. There is no update required. And you can navigate history going from one place to another. Mobile applications, native applications for mobile, have a concept called deep linking, which is very interesting. It allows you, for example, from a restaurant rating app to jump into Google Maps if you tap the address or locate store button. And it allows you to jump into an application already preset in a particular way. So how can we do this in web apps? We're going to be looking at parts of the URL we can leverage to do this. The one we most know about is the path name. The path name defines the content, the page that we are looking at. It is so prominent that most of our frameworks have built abstractions around this concept. In Next.js, for example, to get a path name of /foo/bar, we would have actually two ways of doing this now. In the previous days, in Next, we would use in the pages router. So Next has this concept of routers. I will not go too deep in details on how they work, but they allow you to translate a file on your file system into a route in your URL. So in the pages router, you define it by pages/foo/bar.tsx/gsx. And in the app router, which is the new iteration of this system, you do almost the same thing, except that the leaf file has a different name, allowing you to have other file types next to your page file. So keep in mind, pages router, app router. If you've never done Next, this will become important later. Pages router is what was before, app router is new. So the path name gives us content. We can use also the fragment, everything that's after the hashtag in the URL, for location. If you put a unique ID string onto the ID property of an HTML element, and you put that ID into the URL, the browser will automatically scroll to that thing for you. So this could be very handy if you have a long list. So in terms of deep linking, this gives us this concept of location. So that gives us content and location. What about customization? What about behaviors? What about state? And this is where the query string comes in. Note that there's actually no consensus on what this is called. Query string, search params, query params. I'm not going to do a live count of who calls it what, but I've been looking at the official RFCs, the documentation of what a URL is structured, and even Tim Berners-Lee, the inventor of the web, doesn't seem to be very consistent on what to name those. So, yeah. And so let's do a little demo on what we can do with this. So hopefully, if I swipe, well, let's do it in dark mode, if you guys are okay with dark mode. All right. There we go. So this is a file on GitHub. And it looks all right, but there's a little secret here. This file uses tabs for indentation for a good reason, which is accessibility. Because some people might have difficulty reading code with only 2 spaces as tabs, and they want to have a little bit more. So there is a little thing in the URL up here that you probably can't see at the back, but there's a query param called TS for tab spaces, and it's set to 2. If I set it to 8, then my indentation changes. This is the same content, but there is a little bit of customization that we've applied to it through the query string. So back to the presentation, which is this way. So the query string is a key value store where we can put some things in there. And so to give you a bit more personal approach of what I can do with the query string, let's go back to the pandemic days. During the pandemic, I learned woodworking. We did weird things during the pandemic. And I built this little application with Next that let me design dovetail joints. So it's this fancy way of connecting 2 boards together. And it has these controls, and these controls are mirrored in the URL. And the reason I did that was that I could design the joints on my laptop using all these controls. Actually, probably better if I do a demo of this. Yep. So this is here. Let's go in dark mode because you guys like dark mode. And so I have all these controls here. I can change the number of tails. I can design the joint the way I want with changing those sliders. And if you look at the URL up here, you can see that those numbers are changing as well. So everything is mirrored in the URL, except you can't see it if it goes full screen. So you'll have to trust me on this one. It changes here. And so the reason there was that I could design the joint on my laptop and then copy only the URL to my phone, go to the workshop to do the cutting on my phone because I don't want to bring my laptop in a dusty environment. I actually never ended up using this thing because cutting dovetails is much more fun to do it freehand. But the concept of putting state in the URL just kept coming back. And let's go back to the presentation. And so to do this in Next is a bit verbose, unfortunately. We have APIs to access the search params. We have APIs to update the URL, but there is a lot of imperative glue in between where a lot of things can go wrong. And so I kept using the same pattern, but being frustrated about copy-pasting the same code between my projects, both for myself and my clients. So I ended up putting this on NPM, and I realized that my presentation is desynchronized. There we go. Yeah. On NPM, on a library called Next.js, named after the hook that it implements, useQueryState. So if you've never done React, a quick explainer on how this works. Here we have a component. A component is a piece of UI in your application. This component is a search input where you can type some text. And there are two ways of doing state. The traditional React way of React use states define that we have something that changes, and we get this value called state, and a function to change it called setState. And the default value would be an empty string. So our search input is empty at the beginning. But the problem of using use state is that if you reload the page, it's gone. If you try to move to another machine, it's gone. If you try to bookmark it, it's gone. This is why putting your state in the URL allows you to persist it, and to recall it, to transfer it. And so I really like this API of use state. Value, way to change it. So useQueryState exposes the same thing, the current value that's in the URL and the way to update it. And the only thing it needs on top of that is the name of the key in the query string, key value, to bind it to. And so with this, we now have a concept where we can do that. So let's go to an example. Again, I was really thinking that you guys would like light mode. And so here I have a text field. You know what? I'm actually going to exit this because you need to see the URL while I'm doing that. There we go. And so like if I type hello orchids Rouen, you can see that the URL changes as I type. So they are kept in sync. There you go. Back to the presentation. And so this pattern is useful, and it was being used not just by me, but because I put it on NPM, other people started to use it. People like Vercel, the authors of Next.js, and a small but growing community of users and contributors. The project got some attention. And at some point, I decided to go a bit more high quality with this thing and not just be the side project that I have on my side. And so earlier this year, I renamed it to nuqs, Next Use Query State. Apologies for the name, Next, nuqs, can be a bit confusing. Also, nuqs is an Urdu Arabic word for flaw or defect. I only learned that the hard way with SEO. So make sure you Google the name of your project before you apply it. And my goals for this project is for it to work everywhere, in the app and pages router, which have a few differences that we'll talk about later. I want it to be reliable. Some people use it in production. Vercel uses it in production, so it needs to work. I want it to be type safe. I'm using the type system of TypeScript a lot, and I want to leverage it as much as I can. And finally, I want it to work both on the server and the client. This is more of a new thing in the app router of Next.js. So the app router in question brings some challenges. It introduces the concept of server components, which changes completely the way we think about our React applications. Instead of them being client first and loaded as an SPA as we were shown earlier, then now the server becomes the first entry point in our applications. It is a server-first approach. And so if we go back to our slider example, then it means that every time we want to update the URL, we would have to go through the server, render the whole page just for the URL to update, which is terrible because everything happens on the client. So what we need to solve this is a concept called shallow routing. Shallow routing was an API where we could change the URL in the browser's the address bar without calling the server. A local first approach, essentially. And Next has this concept in the pages router, so the previous ways we were doing things. by using this shallow option here. That doesn't work. There you go. This shallow option of the router that will change the URL tells Next whether or not to talk to the server. And for a good while Next was only supporting the pages router, we mirrored the same API. But there's a problem. The app router did not support this when I migrated nuqs to support it. And so how do we do this? The way this is done is using the history API. This is a web standard API that's available in your browser. It looks like this. You have forward and back, which mirror the ones, the buttons in your browser. But you have also two methods: push state and replace state. Push state will create a new entry in your history, so you can allow it to navigate back to where you were before. And replace state will kind of git squash it to the same place where you are, just replacing the URL. You pass it a state object, which we're not really interested in at the moment, an empty string, which I'll explain in a bit, and the URL you want to change. Why are we not using the state here? Because this only exists during your session, and what we want to do is put the state in the URL itself so that you can share it with others. Because this would only survive a page reload, not be transferable to another place or be bookmarked. Now, there is something that is not really much talked about these APIs. They have rate limits. You cannot spam this API with updates of the URL and expect it to be okay. Browsers will start yelling at you. Chrome and Firefox are good citizens and will allow 50 milliseconds between calls. This is like a rolling window, but on average, it will be safe to call it every 50 milliseconds, essentially. Safari, on the other hand, is a bit more concerning. It has a much lower limit of how many calls you can call. And this used to be twice as bad. So it's getting better, but we're not there yet. But no matter what the number is, we still have to do some throttling. We still have to make sure that we don't update the URL too often, because we would get those errors. And so in nuqs, this is done using a throttling queue. So we have the events coming in blue, which would be when we try to set our state. And in output, in green at the bottom, the actual updates to the URL. And so in between, we have to have this queue that will, for the first event, it's okay to go straight through. But then the second event comes in less than, let's say, 50 milliseconds before after the first one. So we have this queue here where this event is put in, and it comes out after 50 milliseconds. And then from there, it will also know that every event coming after that needs to happen at least 50 milliseconds after the previous one that's been output for it to go through. So all this burst of CDF states will be queued, and the last one wins because we're talking here as, for example, the same key being updated. And so F comes out after 50 milliseconds again. And some time passes, this queue resets, and the next event that comes when it's okay can go through again. And we repeat this process as we go along. So now we have a way to transfer our state into the URL, to write it to the URL, essentially. What about the other way around? What about when the URL changes, hydrating our state into our application? And this is where we realize that the query string is a query string, and all our state might not be strings. So this is where parsing comes in. Parsing allows us to transform the string that's in the URL into something meaningful for our application. Things like numbers. Numbers even have two variants, floating point or of integers. Things like Boolean, things like dates. And even if you don't, like nuqs comes with a set of parsers out of the box that mirror the JavaScript primitives, but you can also make your own if you want to customize how your state might look in the URL. And this is also where we leverage the type system. For example, here, I have a sorting option, whether I want to sort a table ascending or descending. But let's say I was passing it a value that's completely invalid, like banana. My parser should be able to tell me, wait, banana sorting option, I don't know, it's not ascending or descending. I will return null instead. I will tell you that it's invalid. So we have this way of binding certain specific expected values to a literal in TypeScript, which is only a set of allowed values for a specific string. And so when do we need to run these parsers? When does the URL change? The start of time essentially is when the page loads. We want to be able to capture the state of the URL and put it in our app, put it in our states. And so this would be the equivalent of the initialization function in a React state, use state. The other thing that can change is when the users navigates through the app client side using the link component in Next. When you click a link component, not an anchor tag, a link, the big L link, Next will do client-side navigation, changing the URL, potentially calling the server, and then rendering the new page. And so in this case, we need to be able to tell the new page to load the correct things. The third case is a bit of a hack. It's like an edge case, I would say. It's what happens, because we're using a public API from the browser, what if someone else uses it? What if they update the URL? And we don't really know about it. We need to be able to react to that. And the last case is what happens if nuqs updates the URL itself, and we have other hooks in our app that are synchronized to the same key. They all need to be kept in sync. And so Next gives us a hook to do this, an API to do this. It's called the use search params hook, which, as the name implies, reacts to the URL. But it only does so recently. At some point, it was not reactive, this thing. It could allow us to get the search params on the initial load, but not afterwards, because Next did not have support for shallow routing. They added it in 14.2, if I'm not mistaken. And so to support all these versions, we had to resort to some hacks. We had to patch the history methods. Patching is when you take something that's built in the browser, you replace it with your implementation, and inside you would call the original function. And so we're coming back to this empty string argument here. What is that about? If you look at the documentation on MDN, the documentation for web applications, you will see that this is called unused. Please set to an empty string, which is not very practical. But if you look at the history of the history API, pun intended, you would see that this was used at some point for browsers to rename the title of the page in the history stack, which was not very popular. Nobody used it. And so browsers stopped providing support for this thing. It is deprecated and recommended to be used as an empty string. But we can actually use this. If we pass it, because we are wrapping this API ourselves and calling it, we can pass ourselves some messages through this. So if we have this little internal value that we pass when nuqs doesn't update, then we can check if it is this. And if it isn't actually, we know that it's coming from someone else, from the page load, from another piece of code calling the history API. But if we see this thing, we know that we have to handle it a bit differently. But why do we have to handle it differently? Well, parsers can be expensive to call. The basic ones are kind of trivial, but because you can define your own, they could be expensive. I've had some cases of users building their entire app state into a custom parser. Parsing on every change can be wasteful because we already have the JavaScript values inside every hook. So if we know that the update comes from nuqs, there is no need to repropagate it through the URL because we can do so with an event emitter, which is the system we use to call when the URL changes up here to make it propagate down to all the hooks that are implemented in our components. And so this gives us now a way to read the URL, put it in our state, and changing the URL when our state changes, so we have synchronization. And so one day, a user comes and tells us, we have a bug with Next.js canary. What the hell is a canary? It's not the little guy here. Canaries are the beta versions of Next.js. And so my initial reaction when seeing this was like, well, you know, the MIT license says there is no warranty of any kind, but I like software that works. I like software that I can install. It just works. It makes me happy. So I want to be able to test with all the Next.js canaries. And to do so, there was several options. The initial one would be to subscribe to the releases on the GitHub page on Next.js releases. But there are actually a lot of releases. These are the latest versions of Next.js. These are the canaries, at least one, sometimes up to 5 a day. So we need to automate this. What are our options to automate all this? The GitHub API lets us pull all those releases as they come along. So we just need to pull this endpoint, get the publish date, and know if they are recent enough. And so I have a little cron script running on the Raspberry Pi at home that will trigger the CI suite, so continuous integration automated tests, to make sure that everything works fine with those new versions, because I can catch bugs early with this and react to them. Which brings us to testing. How do we test all this? Good tests are the only way to stay sane around this process. When something changes in Next or something changes in nuqs, I want to make sure that everything works. And unfortunately, knowing what a good test is does not require code coverage. It requires behavior coverage, because users will use the application in production. They will behave in a certain way, especially because Next has a lot of controls. Things like we saw differences between the app and the pages router, things between static and dynamic pages. Dynamic pages are the ones where you have an ID, a variable, in the path name. Base path is when you publish your application on a prefix of the base path, so under a subdirectory, so you can have a /blog and /app or /store, which would be different applications. Also behave differently with this. And finally, shallow routing that we saw the introduction was progressive. So how do we test that through all the versions? And initially, we think that we could just mock the thing and say that if we update the URL, it should be let out. But mocks will actually not help us here. We need to follow the golden rule of testing, that a test must fail only if the intention behind the system is not met. So that means if the behavior is not correct. And because we are depending on internals, on the Next.js internals, we also need to follow the Beyoncé rule of software. If you like it, you should put a test on it. And so this is done mostly not with unit testing, but with end-to-end testing, with Cypress. And so with this, I managed to find the bug and look into the Next.js core. By the way, did you know that the Next.js core uses Redux? Who uses Redux here? Nobody. But you use Next, so you use Redux. There you go. Redux is still a valid option if you have a library code, like with known actions and possibilities. For application code, yeah, there are better ways. So now we can test all those versions of Next, all the supported versions with all the controls. And this is only possible now because of Turbo Repo, which is a way to cache and not redo some repetitive things. So there are a lot of upcoming changes in all this ecosystem. React 19 will be published in a couple of days. Next.js will be published a couple of milliseconds after React 19. And nuqs 2 will hopefully follow along for the ride. And so the idea with this would be to give a smaller bundle size. Big thanks to Andre's size limit here. Very helpful. ES modules only, the newest way of doing JavaScript. It's time to drop CommonJS if you can. No more patching internals if we only support the newer versions of Next and React, and hopefully fewer hacks in detecting those versions. And with this, I say thank you. You have a link to the project.